rows and columns. And when the data set is ready, the next step is to apply machine learning models. Most of the times predictive models, sometimes also unsupervised learning. So you apply an algorithm on your data, which creates a model, and this model learns from your data. So it encapsulates the learnings from the data, depending on what you wish to learn. So there are various algorithms which guide it, and will take you through during the course. Okay, I'll share my presentation. I'll share my screen. Give me a sec. Do we have any questions here? I was just trying to set the expectations. If anyone has a question, please ask.
So Avinash, like,
Yeah.
because you're starting up, and it's perfect that you just started, because we don't require much of introductions and all. What we do is, because you already have Reactor there, we can tell everyone that like this whole series is going under Microsoft Reactor Bangalore, and we have Avinash Mishra today, who's going to talk on introduction to machine learning models. And like he has already mentioned, you have two ways to ask questions, but still you are supposed to keep yourself on mute, and possibly if you can keep the videos and everything on mute, so that the session doesn't get interrupted. We are also recording this session so that we can put it on our Reactor Global YouTube account, where you can find all other sessions also. We will share the link in the chat box. And yes, enjoy the session, ask questions, but try to maintain the decorum and try asking questions which are absolutely for the sessions and around the topic which we have today. And yes, like now, yeah, it's off to you, Avinash. You can go ahead and take it.
Sure.
Yeah.
Thank you, Paras. So as Paras already mentioned, so there are few prerequisites which have been already covered in the previous Microsoft Reactor sessions, and you guys will have the link. So most of you, I believe, have already been through those sessions, but those who haven't been, they can also check it. Most of the things are not very much related, but at times you may not understand how a certain code is coming up, or you may not be comfortable with it. So that's because you haven't gone through the prerequisite sessions which preceded this one. So you can always feel free to do so on the link shared by Paras. Okay. So we'll start today, and this topic is around introduction to machine learning models. So this will be your first topic on how do you use machine learning to learn from the data. Machine learning is all about you ensure that the machine learns from the data, and you use some intelligent algorithms to do so. So let's dig deep. Okay. So the first question which someone may ask is, what is machine learning? And will anyone want to answer this question? What is machine learning? Do you guys have some idea? Anyone? Okay. So let's understand.
Hello.
Yes. Yes, please.
Yeah, hi, this is Ganesh. So machine learning means based on the analysis of the data, machine should take the decisions.
Mm-hmm.
That's
Okay.
what my understanding is. Yeah.
No, you're pretty close, and that's what it's all about. It's all about making decisions. So the entire field is about making decisions, or helping organizations or businesses, or maybe scientific disciplines, helping every domain take intelligent decisions. Machine learning is about taking decisions after learning from the data which we already have. So let's say we may have some past knowledge which is already embedded in the data. So let's take a simple example to understand that. Let's say a bank on a daily basis, they approve or disapprove loan applications. Now they have been, let's say there is a bank who has been operating from past 40-50 years, and they have several applicants. In some cases they ended up approving the loan application, in some cases they denied the loan. Now if I want an intelligent algorithm to go through that past data and learn what is that feature or attribute based on which the manager is making that decision. How is it deciding whether to offer the loan or whether to deny the loan? Okay. If this can be learned automatically, so the important part is everyone can go through the data and manually can learn some features. But let's say there is abundance of data and we want intelligent algorithms to learn that from the data. And it at times is explicable. At times we can explain what the learning is. At times it could be a combination of few attributes and slightly tougher to explain. But in both the cases, if you can adequately learn from the data, and that learning can be used to take decisions. So that kind of simulates the way human beings learn. So this is what machine learning does for us. It learns from the data, and we use that learning to predict things for the future. That's one of the parts, one of the important parts. Again, there are other steps involved. When you learn from the data, you need to evaluate how good your learning is. So there has to be a metric which tells us how much did you learn, a kind of assessment for the model. So there are various evaluation metrics depending on the type of model you are training on your past data. And we'll discuss a few more examples and we'll get them into detail. But the high level picture is you learn from the data, you assess how good your learning is, and then if the learning is good enough for as per the business requirement, you use that learning to predict for the future. Is that clear with everyone? Okay. Okay. So now the second thing is, once we understand at a high level what machine learning is, we'll dig deep into algorithms later on. Oh, let's say we have used some intelligent algorithms, learned from the data that learning is good. We have evaluated that learning and we realize that it is good enough for our use. So how do we use that model? So we need to form a pipeline wherein we can import the data from some data source, wherein there is cleaning of data, or let's say feature transformation of that data going on. Then this input is going into the learned model, and the model is predicting. Okay, prediction could be of the type like, let's say, approve or disapprove a loan. So any decision this model is taking, and this entire process is automated for us. So a user may come and they can input their various details. Let's say in this case, maybe the user may enter their name, their age, their, let's say, address, their income statement, their various things, and using maybe their PAN card details, their Aadhaar details, and using these details, sometimes we also talk to a website which tells us, okay, what is the credit score for this account, and we also see a few other things, attributes of that person itself. If he also has an account with us, we see how he has been in the past. Using all this information, and the model takes a decision whether to approve or deny the loan. So the entire thing, when put in place in sequence, is our machine learning pipeline, and we will discuss that towards the end. Then there are other things which we'll talk about. We'll talk about the types of a high level division of what are the various types of machine learning algorithms. We'll discuss the linear models. We'll also discuss the practical modeling, as in how would you apply your learning? How could you be hands-on on what you have learned? How could you apply it in real life? And then what should you do the next? Because this is an introduction session. So the expectation is that you get a fair idea, including hands-on skills, of what is done in data science or machine learning. But what should you do to go forward or move forward on the path is something we'll talk about towards the end. Okay.
I have a couple questions in the chat.
Yes. Let me just
with the help of algorithm, we have to judge what?
Oh, you have to judge what? Okay. So as I say that there are various types of algorithms. So there are some algorithms which do a prediction for the future. So a prediction for the future could be of two types. I can either help or take a decision of classifying something into various subclasses. And what do I mean by classifying? This example which I talked about, whether to approve or disapprove a loan. So one class is approve a loan, the other class is deny the loan. Okay, that's a classification kind of decision which you are taking. There could be more than two classes also. Okay, but when you have to pick amongst two or three or four, you have to pick one class amongst the given outputs. That's a classification decision. There could be a decision wherein you want to know how much loan to approve. If that's the case, it's called a regression type of decision, a decision where you want to know the amount of loan which should be approved for this particular customer. Okay, now the question if you ask is, how does the algorithm learn that, then that depends on the specific algorithm which is doing that learning. And how do we train that? That's what we'll talk about, not in very detail. We'll, because this is an introductory session, so we'll talk about those things, but we'll discuss it at a level where you will understand how it is happening and you can apply it immediately on some data sets. Okay, did I answer your question?
We have 3 more questions. So
Please.
Surendra asked how to create a data pipeline.
Okay, so we'll discuss it towards the end. So first we'll learn how to do model. When we learn how to do model, the previous class was about cleaning the data. So bringing the data of the form so that it could be used as an input to the algorithm. So once you import the data, maybe the data is stored in some database, you import the data, you apply some cleaning methods to the data, so the data is refined for the purpose of going as an input to our algorithm. Then the data, uh, then that data is used to create a model. So you apply the algorithm, let's say it could be linear regression. So this algorithm is applied on the data set, and on the data, it learns what are the right coefficients or the parameters of regression. So, and we'll discuss that in detail because we are covering this algorithm or this model. So then
Hello, Avinash.
algorithm, yes,
Hello.
yes,
Hi, Avinash. This is Kunal here. My
yes,
question, what I asked is like writer algorithm. So you have given an example like bank, right? To
mhm,
approve the loan and reject the loan, right? Two types. So we need to write a separate algorithm for both of things, like one algorithm for approving the loans and second one is for rejecting the loans, kind of
that's
thing.
a very good question. So maybe I did not clarify it in the first stage. So when I say a classification type of algorithm, that means an algorithm which is capable of making that decision for you whether to approve or disapprove. So that algorithm will take that decision. So, and you will never be writing an algorithm from scratch, at least not in the initial days of machine learning or data science. So you will have algorithms. You would devote your time in understanding how to apply these algorithms to the data sets. When you apply this algorithm to a data sets in the right methodology, that creates a model. Now this model takes a decision whether to approve or disapprove a loan. So your goal is to create a robust model. That's your goal. That model will take the classification decision. That model can take a regression kind of decision, that how much loan to approve, or it can take a classification decision like whether to approve or disapprove, or it can take a decision like whether something is red or blue or green. So it can take any decision. You do not need separate algorithms or separate models for taking each decision. It's the same model which is helping you decide which class to go with. Am I clear?
Yes, yes. So you are saying that there is some predefined algorithm is there, and there is some algorithm which we need to write it. So predefined algorithm, whatever there, we need to apply that one. If it is workout, then fine. Otherwise, we need to write the separate algorithm.
Okay, good that you asked. But okay, so let me just clarify. There's a lot of confusion. So there are some algorithms, okay, and there is something called model. A model is different from algorithm. Okay, so algorithm is a, a, a mathematical instruction, step-by-step instruction, which when applied on the data will create a model for us. Okay, so when you apply an algorithm that on a data set, you will come up, the output is a model. That model is what you will use for taking decisions like whether to approve or disapprove a loan, or for predicting the results like how much loan to approve. You will use that model, and it will be clear slowly. We'll take one example and we'll do a hands-on on Python. We'll see how we what was there in the data set and what we did to accomplish our goal. Okay, so if
Okay,
you
got
give,
it. Thank you. I got it. Got it, man.
we'll take one example one by one. So that will be very, very clear. Okay, I'm just describing what's there in the agenda. Is that okay?
Yes, yes. Thanks, Avinash, for the clarification.
Welcome. Well,
1 more question. Uh, Surendra asked how to decide which algorithm will apply in a particular scenario.
wow, that's a great question. So I'll tell you the basic classes of algorithm from the business perspective, and then there are a lot of things which play a vital role in making the decision that exactly which algorithms to apply. So what I mean is that, let's say I tell you that for in case of supervised learning, and I'll tell you what supervised learning is. Supervised learning, this is a specific type of algorithm, family of algorithm, you can say. In this type, there could be various algorithms. Okay, and let's say there could be various regression type and classification type of algorithms. Now, which one to apply? Often, often we do is that there are two ways how we proceed. The one is the knowledge of the complete mathematical construct, as in what are the assumptions of this algorithm, how was this algorithm originally made or devised, what are its pros and cons, and then what is there in your data. And then using all this knowledge, you apply these algorithms on the data, and also you experiment. So it's an experimentation phase. When you say you create a model, you experiment with various models. It's an iterative process. So apply the first algorithm and you get a model, apply the second algorithm and you get a model, and apply the third algorithm and you make some changes or some parameters you change and you get another model. You get these various models, and I talked about in the beginning, there is a way to assess how good a model is. So you assess which model is more robust and which model has a higher, let's say my metric is something like accuracy. So which model is, it can accurately decide for me whether to approve or disapprove the loan. That is a model which decides this with minimum error. Okay, so that is the model which I will use in the future. And in data science, it's very different from software engineering. So it's not a set of steps which you do and get an output. It's a set of steps which you do to bring the data in a shape where you can apply a particular algorithm. And you apply that algorithm and then you update some parameters based on various things which I will talk and which are different for different algorithms. So you cannot sum up them in one line. Okay, but yes, what you do is you iteratively improve your model. You make a model and then you say you assess how good it is and then you improve it. And I talk about how you assess and all the things, but you improve the model iteratively. Once you get a model good enough, then you finalize the model. Okay, I'll deploy this model. I'll make a pipeline. I'll deploy this model. Okay, so I mean, there are various things which play a role in deciding which algorithm to use, with which data set it goes. And at times, apart from that mathematical knowledge, there is a lot of experimentation which goes on. You apply and see what works. Do you get my point? Class, am I clear here?
Surendra typed okay.
Okay, so we'll see it right now. Okay, once we apply it, we'll see it. Let's just start because we simply have 2 hours. So let me just quickly, I'll just be very, let's say, precise here. So I have some 10 plus years of experience in the IT industry and have been working in data science from 5 plus years. I've worked on various projects and I have led multiple teams across geographies, across various countries, including your Middle East and Europe and the US. So I have substantial experience with various types of projects and mentoring various teams. And I'll be taking this session, which you all know. I mean, this is late in the slide, but let's say, and we have discussed at a very high level what machine learning is. These slides will be with you, okay? But the best way to understand it is we'll take a practical example, open the notebook, and see how it works, okay? So, okay, let me just tell you if there is something important here. So there's this music streaming service which uses scikit-learn API, which is a library of Python, which is a machine learning algorithms library. You use this library to import various algorithms, and it uses this to recommend music to various. So this is a kind of machine learning problem, a recommendation engine. And what it does is, uh, because of your past data of what you have heard, and people like you who have similar attributes, like similar in age or similar in profile, who come to this website for listening to music, evaluating that data helps the algorithm generate some recommendations, so it can recommend you the next music. Okay, so that's how they use machine learning. So there could be various ways in which you apply it in the real business context. Let me, and then
Okay,
yes,
I have a question from
yes.
Prachi. How is algorithm different from model?
How is algorithm different from a model? Is that the
Yes.
question? Yes. Okay. So an algorithm is a step-by-step instruction. Okay, so an algorithm is the instruction of what you will do to the data to formulate the model, or what you should be doing. And every algorithm comes with the pros and cons. So you understand that if the data is of this type, you apply this algorithm, which does certain things with data, and we'll talk about what things. Okay, we'll talk when we discuss the algorithm. So we'll talk about what things, and then it creates a model. This model helps me take a decision, or maybe predict something, like give me a number, like how much loan to approve. Or this model may also do a few other things, like clustering the data, how many different clusters exist in the data. At the end of the day, the goal of any algorithm is to do pattern mining, pattern detection. So it takes the data set and detects the important patterns, but which pattern are we really looking for depends on the business problem. What do we want to solve from the data? Okay, so we'll be very, very clear after the first example is over. Is it okay?
Yep.
Did I? Yes.
Yeah, you can continue.
Yeah, so you understand, an algorithm is like, I am telling you that when you get let's say when you get 5 numbers, you have to add them and return the sum of those numbers. It's like a simple program. So you take an input of 5 numbers and you always add them and you return the sum of those 5 numbers at a very, very high level, although it's not very correct because there's not a machine learning algorithm, but it is an algorithm for adding numbers. Okay, so an algorithm is a step-by-step process. It can take any 5 numbers and it can give the result every time. Okay, that's algorithm. A machine learning algorithm is an intelligent algorithm, so it doesn't do a specific task of taking 5 numbers and giving the result, which is a very straightforward task. A machine learning algorithms helps us predict the future. Okay, what is good, what is the right decision for the future? I mean, and no one can know the future, right? So predicting future is pretty tough. So what machine learning algorithm does is it tells you that, okay, if you offer a loan to this particular person, there is this much probability that he will or she will repay the loan, and this much probability that he or she may not be able to pay the loan. And based on those probabilities, you as a business person take the decision. Do you get my point?
Yes, Avinash, you can go
Oh,
ahead.
great, great. Okay, so our regular pipeline consists of data collections, where I was talking about importing data from some database, or at times there is unstructured data. So you can crawl the web and get some data from various websites. So data collection is the first point. Next comes the data cleansing. Now, data cleansing depends on what do you want to do with the data. So let's say I have crawled the web and got some natural language data, some English text. Maybe I need to do something else, versus if I have downloaded data from a database of various customers of a bank, then maybe I need to do something else. But data cleansing is about what do I do in the data before I can think of applying any algorithm to it. Then next comes feature extraction, creating new features out of data. So data may have some features. A feature could be, let's say my date of birth is there in the data. Okay, my date of birth is there. As a customer of the bank records my date of birth. Is that attribute very, very useful for the bank? Maybe not. But maybe it is very useful for the bank. But what I mean is that attribute very useful for the machine learning algorithm? Maybe not. And you will realize it when we talk about it, when we talk about the algorithm. But what attribute could be useful? Maybe the age of the person is a useful attribute. It doesn't matter what is my date of birth, but I can find my age from it. So given that I have the information of date of birth, I can extract a new feature called age from it. Okay. Then the next step may be, let's say I have a customer of the bank who is 24 years of age, another customer who is 26 years of age. Now the question is a 24 years customer very different from a 26 years old customer? If yes, then maybe I can treat them differently, and my algorithm should treat them as two different customers. Otherwise, if they are more or less the same, if they are more or less they have similar level of maturity, or they have the similar level of income, then what it should do is it should club the age as, okay, everyone between 20 to 30. These customers, I form a bucket and I apply the same technique on the bucket. So there are various things which you do in feature extraction. It also depends on what algorithm are you using. So first step is data cleaning, which often involves, let's say, removing rows and columns. which have null values, or which may have values which might not be apt for your machine learning algorithm, or which may have wrong values because of some data entry. You want to clean that before you apply your algorithm. Okay, or at times there are outliers, so which has been covered in the previous sessions. Okay, then comes feature extraction, which I just talked about. Then is the next step, model training. So you train your model on a data, which is like you apply the algorithm on the data, and because this application is in an iterative fashion, so you apply your algorithm to the data and you create a model. You create a model, you improve the model, so you apply it again and you improve it. You change the parameters, you improve it. Sometimes you apply a different algorithm and you keep on improving it till you are satisfied with your results, because you can find your results, because there is a way you can evaluate how good your model is. So once you do that, that completes your model training. Model training, you are satisfied with the results of the training. Still, you have kept some data aside. So because you have trained your model on the data and then you are testing it on that data. Now that training seems to be complete, model seems to be working fairly well, but it is yet to see unseen data, the data it has not seen. Let's see whether my model has learned the required attributes or not. So we apply this on a data set which the model has not seen during the training time. And that's where we evaluate the model. That's final evaluation of my model. So I train my model. I also test it on the training data itself to see am I learning or not, and improvise the model in an iterative fashion. But finally, I would want to test my model or evaluate my model on a piece of data set which it has not seen, to see how well my model generalizes. Okay, and this generalization of a model is the feature called the robustness or the goodness of model. So model should be able to generalize well on unseen data sets. So we evaluate the model, and once this is complete and we are satisfied with the results, then we deploy the model. We ensure that the model is put in production and things are automated, and then model serving is there, so you can use the model day in, day out. Okay, so that's the usual process one follows in a machine learning pipeline. Now, everything here is clear, but we did not discuss about algorithms or creating the model, and that is the agenda for today. Okay, all these things, data collection, cleansing, and extraction, has been done in previous sessions, and evaluation, deployment, and serving is kind of clear. But what is the major step is model training. Model training will involve understanding which algorithm to apply and train the data, create a model out of it. Okay, so we'll do that on the notebooks today. What kind of models we'll be dealing with? So, okay, there is one family of modeling called predictive analytics models. And these models helps us take various kind of decisions like whether to approve or disapprove a loan, or how much loan to give. So these are the common families of algorithms which helps us either predict a number, a numeric value for the future. So I'm trying to predict how much loan to approve. So I'm trying to predict the number, whether it should be 1.5 lakhs or 3.5 lakhs. Okay, so how much loan should I give to this customer? How much it is? How much do I know will he comfortably return to me? What is his paying capacity? Okay, so that comes under a specific type of predictive models, wherein I'm trying to find out I'm trying to regress the attributes I know, or I'm trying to find out a number based on the attributes I know. And we'll talk about that, and we'll take the first example at that. Often called linear regression, but there are different other types of regression also. There are various non-linear regressions like tree-based regressions and other regressions, and we'll discuss one of them, and I'll tell you other things in detail. Okay, but there are other decisions like whether to approve or disapprove a loan. This kind of decision, which class should I put a particular data set in, a particular record in? A particular customer comes to my branch, should I approve a loan or disapprove a loan? Now this is a different kind of decision. I'm not saying how much to approve. My output should be yes or no. My output should be how much, whether I give offer a loan or whether I deny a loan. So that's what I'm looking for. That's called a classification kind of model. So these are predictive models. There are other kind of models which are there are preemptive models which assess the risk. So these models can help us find a line. Let's say I'm analyzing machine generated data, and I can tell if the machine is going to have a downtime, if it requires a repair. I can tell in advance that this machine might go abrupt in next 2 hours, and it's a good time to have this thing in place. So by, let's say, analyzing the frequency generated by the machine, by analyzing the let's say heat generated by the machine, by analyzing various things, the model can automatically say that this machine is going to go down. Okay, and this has been used extensively. It is used in telecom. So let's say you have these various towers, telephone towers. So earlier what happened was people used to, so we all understand mobile technology at a high level. We understand that how do we make a call. We make a call and the signal the antenna of our mobile is taking a signal from a nearby tower. From that nearby tower, it understands and we make a call and that signal is transmitted to the next tower and so to the next tower till we reach the receiver whose nearest tower is connected to his or her mobile, and then he or she hears. But what happens is these towers save a lot of data, not just the communication which I'm making, but there is a lot of noise which was not used. That's not very that's not good enough signal to be passed on to the next tower, and that was considered as noise generated by these towers. So we used to discard the data, and almost like 90 to 95% of the data generated by these towers was discarded. When data science came into being, they realized that I can use this data, which is considered as noise, to find out when this tower is going to be out of service. And I can find that out a few hours in advance. So before a tower goes out of service, it produces a different kind of frequency, and maybe I can catch it from that additional data which I'm throwing away, considering it as noise. So the definition of noise is revised itself. So that noise becomes important data for me now. If you all get my point. So that's called preemptive analytics. Preemptive, I can preempt various things and I can mitigate risk based on it. Okay. There are other things like prescriptive analytics, where I analyze something and I can prescribe back to the business what is good for them, what is that they should do to maybe increase their profits or mitigate their losses. Okay. So various things can be done using these basic models, and this is an introductory class. We'll start with two predictive modeling techniques, regression and classification techniques, but I'll give you a good enough feel to understand that how it is actually working. You'll not know all the algorithms, but whatever we discuss, you will know them in detail. Okay. So let's understand. So this is some data set of age of people, income, education level, moderate, high, low, which could be something like someone who's a 10+2 versus a graduate versus a postgraduate. Okay, gender, and this is the decision we want to take about that person. And based on his income, I would want to know whether he would prefer renting a house or buying a house. So if I know this in advance from the data, I can approach the right customer. What if I approach a customer for buying a house or purchasing a house when he's not the right fit for it? So this thing which is called class label, this is a classification thing. I use this data set, I use these features to predict whether a particular customer will prefer buying a house or renting a house. And because I know this in advance, the right person can call him. Do we get my point, class?
Hello, Avinash.
Yes.
Yeah, I have one question here. Based on his salary, how you can decide that it is going for to buy a house or it's going to rent a house?
Okay. I'm not saying I'm deciding it based on his salary. I'm also not saying I'm deciding it based on his age or education or gender. Each of these attributes, when looked at individually, do not tell me whether a person buys a house or rents a house. Okay? Because a person of every age can buy or rent, and every income can buy or rent, or every education can buy or rent, or every gender can buy or rent. But these four attributes, when taken together, they form a four-dimensional plane for me. On that plane, I'm trying to classify those who buy versus those who rent. So I'm trying to make a good enough model which cannot 100%, which cannot like super accurately predict this, but it can say with a given level of accuracy. So maybe with a 90% accuracy, it can tell you every time that whether sometimes 10% times it will go wrong. Do you get my point?
Yeah, I got your point, but the thing is that I didn't understand till now that like how on what basis this algorithm is deciding that it will be buying a house or renting a house.
Two things. First, this data set in the presentation is not an actual data set. So it is given
Yeah.
for you
Okay.
to understand. Okay, first thing.
Yeah.
Second thing, how algorithm is deciding is something when we take the example, you will see how it is working. Okay, so
Okay.
let's say for my algorithm, this age, income, education, and gender, they are my like x1, x2, x3, x4. These are independent variables. So therefore, say what we know, features, attributes. The other way to understand this is these are easy to know attributes. So let's say if a customer comes to the bank for asking for loan, applying for a loan, so I can ask the customer's age, I can ask his let's say income, I can ask various things. I can collect that information on the form. Also, based on that information, let's say his PAN card and Aadhaar details, I can also find out from a central authority the credit score and various things, right? So these are easy to know attributes. But this one, what we are trying to predict, is a difficult to know attribute. Can you tell in advance that whether it's good to offer a loan to this person or we should deny the loan? We don't know, right? Because future is pretty tricky. We do not know, and this is a very tough decision, right? So how has it been taken in the past? In the past, people who had high say lots of experience dealing with various customers, let's say some 10-20 years of experience as a loan manager, they were very good at deciding whether to accept or deny a loan. Okay, now what data science is doing is trying to understand what do they realize, what do they find from the data, what are they using, and we are trying to automate this process. And the third thing and the most important thing, one person in his 20 years of experience can only meet a certain number of customers, but a data science algorithms can take inputs from all such loan managers across the globe and see what all of them are using to take decisions and build the best algorithm which can supersede the decisions of all such loan managers. Do you get my point?
Yes. 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 Got it.
It won't make sense. Okay, don't worry. So therefore, data science is so popular because so it is not doing something magical, which often believed when not understood clearly. But what it is doing is completely rational and a mathematical decision. The way you start in data science is one way is you do go through the rigorous maths. You study maths for let's say next 5-7 years. You understand everything, and then you come, you learn some programming language, and you apply the algorithm. But the easier way to get into data science, which I believe most of us are here for, is to learn enough programming, know things at a high level, get into a data science job, or start working in data science as a machine learning engineer where I apply algorithms, get some results under guidance of some data scientist, and slowly I pick up the maths. I understand what is happening and why it is rational. Okay? Does it make sense?
Yes, Avinash.
Okay, so now understand. Now there are types of algorithms, supervised and unsupervised. Supervised algorithms are where we have this kind of value, where we have a thing to predict, a class. It doesn't have to be a class label like buy or rent. It doesn't have to be approve or deny a loan. It could be anything. A y could be anything like a dependent variable. It can also be a value like how much loan to approve. Okay, but as long as I have a y means a dependent variable, and I hope most of us are clear what is a dependent variable. A dependent variable is whose value depends on these independent variables, this x1, x2, age, income, education, gender. Okay, so if I have a dependent variable, something which is very tough to find out, which is a hard question to answer, that's a dependent variable. Something which is easy to know, I can simply ask the person what is his age, what is his income. That's easy to know. These are my independent variables. If I can formulate a model could be something like an equation I can come up with some level of accuracy. So if I come up with fx, a function of x, which is a function of age, income, education, and gender, and somehow that function in some way, whether in a linear or non-linear way, I can say in a linear way something like some coefficient times age plus some coefficient times income plus some coefficient times education plus some coefficient times gender, would it tell me whether the person will buy or rent? And if I use that all the time, then I'm correct 90% of the times in the past data. Okay, so that forms my model. If I use that on the unseen data, the assumption is if the unseen data is coming from the same kind of population distribution, I'll be correct 90% of time, even on the unseen data. Do you get my point? So when we talk about supervised algorithms are where we have a class, where we have a dependent variable, a y is there. It could be a number like how much loan to approve, or it could be a class whether to approve or not. But it is a supervised because I have a y based Because of this why, I'm trying to come up with a model which can predict the why for me, which can predict the dependent variable for me. The dependent variable could be how much loan to approve or whether to give or not. Both these things are dependent. So if I'm trying to model all the independent variables by keeping in mind that I have to predict the dependent variables at some point of time, then it's called supervised machine learning. And the common algorithms are regression and classification. Regression means you predict a number, like how much loan to approve. Classification means whether to approve or not. You decide into class. That's supervised learning. When it comes to unsupervised learning, it is mostly about learning patterns from the data, but not with a dependent variable in mind. So patterns could help me cluster the data. So questions I'm trying to answer is, let's say I'm a t-shirt manufacturer. I would want to know, given the Indian subpopulation, if that's my initial market, how many types of t-shirts should I produce? Should I produce medium, large, and extra large, or should I go for small, medium, large, or should I go for extra small, extra small, large, medium, and then extra large? How many segments should I go in? Okay, how many clusters are the best fit so that I get optimal profit? Why is a new business? So obviously, if I cater to all the audience, I'll get profit, but I'll incur money. So what is the segment I should focus on where I incur less money and get more profits? Do you get my point? So what is the best way to cluster things, to group things together, and various other types? So that could be clustering algorithms. There are recommendation algorithms where the algorithm will tell which next best song to suggest, or let's say which next movie to suggest, or Amazon can recommend which product you should be buying. So those kind of algorithms come under the family of unsupervised algorithms, where my decision is not based on a dependent variable, but the decision is taken by understanding the patterns in the data very well. Does that make sense? And they are like different separate families, and there are various algorithms in supervised and various in unsupervised. And supervised can be further classified into regression and classification. Okay. Now, once we do this, then everything is clear. So you acquire the data, which is data import, you clean the data, and then you build the model, you train it, you test it, and you predict. Model is good enough. Okay. So, and these steps, the last block could be iterative in nature, wherein you train and you build a model, and then you again assess, and then you retrain it. So this could be iterative. Okay. And we'll take the first example, regression, and we'll use the housing data set. Here we are trying to predict the price of a particular house. Okay. Next thing, we'll take a classification algorithm, and we'll take the Titanic data set where we are trying to predict whether someone survived in this Titanic accident or they did not survive. Okay. So we'll take these regression and classification. We'll deal with the classification with two different algorithms. One is logistic, another is decision tree. And let me just open the notebook here. One sec.
Avinash, can you make it the slide in the full screen mode?
Oh, sure. I am sorry. Is that okay? Yeah, but let me just open the Jupyter notebook.
Yeah, now it's fine. But next time if you're teaching, then you can make it a full screen. It will be visible. Hello? Hello?
Let me share the, yes.
Yeah, fine. Now fine. Thank you.
Fine. Okay. Is my screen visible? I'm trying to show a Jupyter notebook on the screen. Machine learning.
Yes.
Visible.
Yes.
Okay.
Yeah.
So plus,
Okay,
whatever.
I have a couple of questions in the chat.
Yes, please. You have some questions?
Yeah, so Surendra asked how to choose dependent and independent variable in a data set.
You don't make that choice. You don't make that choice. The choice is made by the business. So let's say you are a bank. What is the problem you're trying to solve? So the tougher problem for you is, should you approve the loan or disapprove the loan? Or the tougher problem for you is that whether how much loan to give. Should I give him like a loan of 10 lakhs or maybe just 5 lakhs? How much is he worth of? Okay, so these are tougher questions to answer. The question for which bank or let's say experienced people, they rely on their experience. They know that they could be wrong, but these are tough questions. They can never be completely right? So they are still taking decisions, but at times bank approves a loan and the person doesn't pay it back. At times the bank denies a loan, but maybe the person was credit worthy. He had this person have been given a loan, he would have paid back to the bank, but bank has taken a wrong decision by denying his loan. So both kind of mistakes are done by the bank because these are tougher problems to solve. So whenever the business has tough problems to solve, these tough problems become our dependent variable. Independent variables, easy to know attributes like what is the age, what is the income, using age and income and pan card number, can I find the trade value of the customer? So all these are easy questions because I can always know for certain what is the exact answer for my question. Okay, so easy to know attributes become my independent variables. These are the variables which help me formulate a model so that I can predict the dependent one. Okay, so the problem which is the business trying to solve is often treated as dependent variable, and the business is already doing that. And in terms of how are they doing that, they're trying to find a dependent variable in terms of various independent variables, and it will be clear in this example. Okay, the example I'm going to come up with, this will be very clear. So as I said, housing price. So let's say I have to predict what would be the price of a particular house. Okay, that's a tough problem because if it is my house versus your house, even if we have exactly the same house, you may decide a different price tag for your house and I may decide a different one. So it could be a difficult problem to solve because you cannot know without asking the person, right? But you would want to know in advance. That's your problem as a business. So what you do is you look at other attributes like what is the locality in which the house is. You look at attributes like, okay, how many rooms are there in the house? You look at attributes like whether there is a marble finish or a wood finish, what kind of paints are there on the walls, how is the exterior, or is there car parking or not? And based on these attributes, you try to predict what is the price of the house. Okay, it's not that you exactly predict the price of the house, but what you're trying to be, you are trying to be as close as possible. Do you get my point? Plus,
Yeah, I have one more question.
yes, please.
I think a couple more questions. So Sanjay asked, how critical are the assumptions made in algorithm?
Oh, they are very critical. Trust me, they're very critical. The short answer, the long answer could be: let's first take an example and let me complete the regression, and then you can ask me follow-up questions if that makes sense. Because I would want all of you to see at least one example, small enough, that's fine, but one example where you take a data set, you decide on the independent dependent variable, you build a model on top of it, and then you predict for the future, and then you see how good your model is. Okay, so that whatever I've been talking about, it makes sense. Is that okay?
Yep. Okay. So Janish asked, can we have the Jupyter notebook side by side so that we can to perform the hands-on while you are teaching?
You can have it side by side. I'm not sure. Paras, are you there on the call?
Okay. So I
Can
think
they?
they are talking about the presentation and the Jupyter notebook.
Okay, so I believe there is a link we can share with them.
Yeah. Uh, you can drop the GitHub repository link, maybe.
Okay, GitHub repository link, but that will take time. They will not be able to do it side by side. So, class.
All right then. So maybe, guys, you can. Yeah. So
Okay,
maybe they can watch it right now, and then they can perform it again by themselves while watching the recording of
okay.
this.
So, class, this session is recorded. Okay. So, at the moment, I would want you to pay attention on what I am saying, and pay attention on how am I doing it. Later on, you'll have the recording, so you can watch it and then try it. You'll have the notebooks and the slides. I believe there is a specific reason why it has not been shared with you, because we do not want you to lose focus in doing things based listening to me. Okay, listening to me is more important. So listen to me, and then you can also try it. And if there is any chance that there is something which doesn't work, or maybe something which is not clear or not in sync with what I have said, you can always get back to us, and I will reply you on whatever your doubts are. Is that okay? class?
Yep.
Yes,
All
it's
right.
perfect. It's perfect.
Oh, good. Great. So now let's everyone focus on my screen and let's try to understand what I'm talking about. Okay. This is more important than running the code. Running the code is the easy part. Okay. And there are a lot of details in the files where you can also go through it and understand. Means everything I'm talking about is also written there. So you'll have, and plus the session is recorded. Okay. So let's look at here and let's take our first example. So as I said, the first example is housing dataset sample.csv. So let me also show you the file if I can. Give me a sec. Housing dataset sample. Okay. So class, do you see my screen? The Excel file on my screen? Class?
Yes.
Yes. Okay. So this is how the data set. This is the sample file which I'm going to read right now, and then there is a bigger file also. But this is how the data set looks like in Excel. Okay. Everyone is comfortable with CSV and Excel files. So I just want you to have a feel of the data. This data set has these columns: average area, uh, income, average area, house, age. What is this? Average area, number of rooms, average area, number of bedrooms, area, population, price, and address. Something like this. Okay. So this is just a sample data, and there are some columns. Let's see how do we read this data in Python using pandas, and how do we make sense of this? So I'm closing this Excel, and I'll read it in Python. Okay. So now let's get back to our screen. So what do? We import pandas. Most of you, I believe, know this library. This library is used to read structured files like Excel sheets or CSV, TSV files. Okay. So pandas makes a data frame from this file on which we can do our analysis. So we import pandas. NumPy is a package on which pandas is based on, and it provides additional functionalities and a deeper level of control, and we often use it here and there. So we import pandas and NumPy. Usually it is a default package which we always import in Python. Okay, because all the manipulation things are done using NumPy and pandas. And those who had the previous sessions where data manipulation and wrangling was done, everything was done in pandas and NumPy. And this matplotlib, this is a visualization package. So you can visualize how the data set looks like, and you can create several plots and graphs out of it. Okay? This line, matplotlib inline, just simply ensures that you can see the graph in the Jupyter notebook itself versus saving the graph in a folder or in the form of a PNG file somewhere. So you can see it in the notebook itself. And Seaborn is again a visualization package. This is based on matplotlib. The way pandas is built on NumPy, Seaborn is built on matplotlib. Okay, so we import these packages. That's our first thing. And then let me just clear all the cells. Give me a sec so that you see a completely clear screen. Okay.
Avinash.
Yes. Yes.
Sorry to disturb you. This actually I'm not in the last session,
Mm-hmm.
so I'm not sure about what is these pandas and all things. So can you give little bit so that I can get some?
That's what I was doing. So, okay, first thing that you will not understand it completely because this session is devoted to machine learning models and not to data manipulation and wrangling, which is the step before building a machine learning model. So you should watch those sessions, but you will have a fair idea. I'll talk about what are you doing with these packages. So pandas is a library which is built on top of NumPy. NumPy is numerical Python. It is a library which deals with these uh, arrays and matrices. Okay, so anything which has to do with number, this NumPy library is written in C language, so it is way faster, very fast, and Python can import it and then use it for data manipulation. So data at the end of the day is read as a matrix, and any numerical techniques we use NumPy library, so they are faster. It's not that we cannot do it in straight away Python, but Python would be way slower. Okay, pandas is a package which is built on top of NumPy. So NumPy, as it is n-dimensional arrays, as it is arrays, and they go with the C definition of arrays where each and every data type should be same, whereas at times we require that in a data set maybe the first column is age, which could be a numeric type, but the second column could be address, which is a string type. So maybe I need to deal with a matrix where there are different data types. So then pandas makes more sense, which is nothing but different numpy arrays. Each column becomes a numpy array and they are stacked together. So then I can read it in a data frame. Those who know the R programming language can understand that pandas are inspired from the data frames of R language. Okay, they are very good for data manipulation. So at the moment I'll read the file in pandas and you'll see how easy it is now versus if I have to write a code for everything. It simplifies my job, that's it, and it is also fast. Okay, so NumPy numerical Python, pandas is based on NumPy for dealing with data sets which have different data types, which is always the case 99% of times. Then we have matplotlib to draw plots, graphs from the data, and we have Seaborn, which is built on top of matplotlib, which provides extra facilities the way pandas provides on top of NumPy. Okay, the details of how we use the package, and there are various things which you can do. There are numerous things, and we can have like a week session on these code libraries. Okay, but the intent is not. The intent is used to use the scikit-learn package, which does the machine learning modeling, which we will be doing today. Okay, we will be using these. Yes, please.
Can you please just zoom in a bit and maybe put
Sure,
the browser on?
Sure. How about now? Is it better? How about now?
Yeah,
it's better. Okay, sorry. So we are starting from here, and I've zoomed in on the browser. Okay, so first thing what I'm doing is I'm importing some libraries which I know for sure I'll be using. Okay, so NumPy and pandas I will be using for even reading a file. So I read a file in pandas data frame. Matplotlib I'll be using in Seaborn for any kind of visualization from that file, any kind of plots I need to draw from the columns. Okay, so I'll just simply import these packages, and I do a control enter in Jupyter Notebook and import them. This pandas as PD is that I can use PD as an acronym for pandas. So whenever I need some class of PD is the object of pandas class. So now I can do pd.read CSV and read a file. Okay. Similarly, NP is an object of NumPy because this is just a variable name given to it. You can also have different names here. PLT is an object of matplotlib.pyplot. Okay. SNS is an object of Seaborn, but you can have any name here. You can simply have S. These are variables. Is that clear, class? Class. I hope everyone has some programming experience. Is that correct?
Yes.
Can we read it from GitHub?
I'm sorry?
Surendra asked, can we read it from a GitHub path?
Yes, you can read it from a GitHub path too, and the GitHub path will also be shared after the session, along with the slides, and wherever these codes are posted on the GitHub, that will be shared. But at the moment, I would ask you to concentrate on the screen and try. So I'll tell you everything which is there in the file, each and every word. But I would want you to listen to me now instead of listening to the recording later on, because now is the time when you can ask me a question directly. Is that okay? So these are the packages, pandas, NumPy, and all that. Okay, now what I do is this PD, which is nothing but an object of the pandas class. Okay, this variable pandas is PD. I could have written it as P. Okay, so PD, I can call any functionality of the pandas class, and there is one function called read CSV, which is used to read a CSV file. And in this read CSV function, I have given the file path. Now, if you look at my folder structure, you will realize that, okay, this is my code. This is where the code is. This one, second, 2 machine learning models. This is my code file, 2 machine learning models. And this is a data file. This is data. And within this data file, I have this housing dataset sample. These are 2 files, right? So I have given the path so that in the code file, in the same folder, you go to the data, and inside the data, you go to this file, housing dataset sample.csv. Okay, so that I believe that part is simple. And then, so this complete file is read in a variable called df, where df is just a variable name, although we use this commonly because it is a data frame. We know that pandas using this structured data will create a data frame object, and we often call it df, but we can call it anything else also. Okay, so df is pd.read csv, and I've read the file. And then this thing, if you just comment this line and you read it, this will not create any output for you. It will only read the file. So file is read, but you don't see anything. You want to see a head of the file. What do you see in the file? So you can see the entire file, and you can see also just the head. So if you do a df.head, you see the file. So now in this data frame, I want to see a head. Head means I want to see first 5 rows. So let's say 0, 1, 2, 3, 4. I know this average area income, average area house. These are my column names, right? The first line was header. By default, Pandas assumes the first line is the header line. Okay? And I'm just asking for the head, df.head. So first 5 rows, which are numbered from 0 to 4. And these are the values in those rows. Does that make sense, class? It's the same thing which I was showing on the Excel sheet. That's how you read it in Python.
Sir, so can you hear me?
Yes, I can.
Yeah, sir, this DF is automatically created, right? When we import the pandas, so this DF variable is automatically created, right?
No. That's not the case. So let me see. Let me tell you something. So this DF is a variable name I provided. Let me write it data. Okay. So now, whatever I'm reading, pd.readcsv, pd was a variable I gave for the pandas class. So I say an object of panda, I import pandas class, and I say as pd. So I need an object with the name of pd. So I can use this object. Do you know, if you know, anyone, if you know object-oriented programming, I can use this pd to call all the functions which are defined in pandas. Pandas has a read CSV function defined for reading CSV files. And I have a CSV file in this folder. Okay, so I'm using pd.readcsv and reading this file. There are other parameters which can be provided, but this is the simplest way. By default, it skips the header line and it reads the file, and I can save it in something called a data. Okay? That's not a problem. I don't have to be df. Okay, and in that case, I can write a data.head. So I write a data.head, and still it will work. Okay, so it's not that it will not. You get the point. This is a variable. You can also say it something like my name is Avinash. Call it Avinash. It will still work. This is a variable name. Even these pandas object like PD, I can call it, instead of PD, I can call it Rohan. Pandas as Rohan. But I'll have to every time write Rohan.readcsv, which is a very big name. Okay, and also it is more understandable. If I do PD, I know I'm talking about pandas. Do you get my point, everyone? Okay.
Yes.
So now let me just change it to df, because later on in the code we are using it as df. Okay, so good that you asked that question. It is beneficial for everyone here. Okay, anyways, I've read the file. I've just asked, if I do simple df, I don't write a head, what will happen? I'll get the entire data frame. So if you do a df, what do you get? You get the entire data frame. You can look at this. This is the entire data frame, and it has got, after 0, 1, 2, 3, 4, then I have this dot. That means these are many rows which are missing. And then I go to 4995 and something till I reach the end, which is 4999. Do you get that? It is 5,000 rows and 7 columns are there in the data. Do you get the point, class? Class, does everyone understand?
Yes, got it.
Okay.
Yes.
Now, because this could be very, I could have 10,000 or maybe 10 lakh records. I don't know. So a better technique is when you do not know the size of the data. One thing is what you can do is you can do a df.shape. This will tell me what is the size of the data. So I can see this data set has 5,000 rows and 7 columns. Okay. Then what else can I do? When I know it is 5,000, I can either read the entire data frame, or I can do something like df.head, which will give me first 5 rows. And this will help me understand. So I'll not have an overflow of the data, and I'll understand. I'll look at each of the attribute and understand, okay, this is how address looks like. This is how price looks like.
Hello, Avinash.
Yes, please.
Yeah, I have one small question here. Like, if you're doing a df.head, we are getting the only 5 records, right? So requirement is that
how many records you want. You can write 10 in the brackets.
requirement
Right?
is that we have like 6 or 10 records. Then on that case,
In that case, you can just, if you want 6 and 10 records, then you can say head, and then in the parameter you can pass 10. So by default it gives 5, right?
okay, by default it's giving 5, but df.head bracket I'm using 10.
Yes,
so
you can use 10, you'll get 10 records. Yeah.
Okay.
But the problem is, let's say the data set does not have 10 records. You could also get an error. Do you get my point?
Yes.
Yes. So always check the shape before doing anything. Otherwise, run the default things. It will not throw an error in case of default. Okay, even if it doesn't have 5 records, it will not throw error.
So
Okay.
in that case, if I do df dot head of 10, remaining 5 will be blank, right? Why it will
No,
give
no, it does not have those index numbers in the dataset. So it's like you're trying to call some index number which is not present in the dataset.
okay.
Okay. Anyways, apart from head, you can also do tail. Anyways, in this class, focus on what do I take care of while creating a machine learning model. Please do not lose your focus and get into what are the ways of doing Python and what are the various, let's say, uh, what do I say? What are the various parameters in a function and all those things. Okay, this information is present on Google, on Python's website, and on everywhere. So don't worry about the engineering information. Okay, and you in real life you don't even have to learn it. What you do is when you start doing jobs with Python, you on your own remember it. Do you get my point? So do not focus on those things. Whenever you don't know something, Google it out. Okay, but focus on what we are doing and why we are doing it and how we are doing it. You can always find the commands for it later on Google. Is that correct, class? So what do I want to know?
Yes, sir. Yes.
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 What do I want to know? First thing I
Yes.
would want
This.
to know.
Uh, Sir, can you hear
Yes,
me, sir? Yeah,
I
yeah. What you said is right, sir. What you said is right. Why? Because this session is meant for like giving the deep insight of the machine learning models. So that's
yes.
what all the participants are intended to. So I hope let us go on that path. What I'm saying is right. All right, sir. No need to get into the much on the coding. So what is kind of what you are trying to intended to say? That's what we are looking for. Yeah.
Okay, great. Thank you. So class, once again, so I am trying to introduce a machine learning models as a topic to you all, and you have to understand that this is a super complex topic. Anyone who tells you that this is easy is hiding truth from you. But the intent is not to get into complexity and get quickly started with it. Once you get started with it, when I started with data science, I did not know everything I know today. Okay, you understand things at some level and you start with it and you slowly grow while you learn. So get into that way where there are abstractions built. So no one would know everything about a car before driving a car. If your intent is to drive a car, you would not know every details of the engine of the car, would you? No, not on the first day at least. Yeah, if you drive the car for a few years, you will know a lot of things about the car. Okay, so I would ask each one of you to take this session for getting into data science. Later on, things will come to you and it will take time. You don't have to have all answers today, but anything related to direction, insight, understanding, feel free to ask. Coding part, you can always search. You can also ask me, not a problem, but that will waste a little of time. Okay, just in the context of time. Okay, so apart from reading the shape, I can see a head and tail and I know these things. I can have various parameters I can find out. I can do a df dot columns. So just that in this data, it was easy. I already knew that these are the columns. I have 1, 2, 3, 4, 5, 6, 7 columns. But what if I had 17 columns or 170 columns? Then I'll have a scroll bar here and this will go after address to more data. And let's say I want to list those columns because if there are 170 columns, I cannot see them in one go. So what I can do is I can do a df dot columns. That will give me an array of all the column names. Okay, so I know these are my column names 1, 2, 3, 4, 5, 6, 7. Okay, and d type is object, which simply means that this is of type object. That means these column names are string. That's another thing. Okay, now let's do some exercise. Okay, df dot describe. Let's understand. Let's not do the transpose first. Let's do a describe first, and then I'll do the transpose. What does describe do? For all the columns which are numerical in nature. So if you look at here, you'll have 6 columns numeric in nature. There's one column which is not numeric in nature, and which is that column? That is address column, right? This column is non-numeric. Rest all the columns are numeric. Do we all realize that, class? Class?
Yes, yes, sir. Yes, yes.
Okay, you can call me Avinash. Okay, so for all the numeric columns, the describe method, it gives me various statistics about these columns. So what are various common statistics, which are important statistics, like how many records are there, which is there in count. And for each one of them, I know 5,000 records are there because I also saw the shape. So I know 5,000 records are there. Okay. This is another way of writing 5,000. I write 5.00 into 10 power 3, which is also 5,000. Okay. So don't worry. It is writing it this way because price as an attribute is taken as float, and therefore this is how it is representing it. The others are integers. But don't worry. So count is one thing which is giving me the count of number of rows for that column. And each column is having equal number of rows. This is a regular matrix. And we already know the shape of the data is 5,000 cross 7. So the count will have the same value of 5,000 everywhere. Then there is mean. Mean is what is the average of the values of this first column, average area income. So whatever is the average area income value, I find an arithmetic mean. So I add them all up and divide by 5,000, and this is what I get: 68583.108984. So this gives me a mean of the column. This gives me a mean of the second column, house age, mean of the third column, fourth column, fifth column, and sixth column. Obviously, we are not taking non-numeric columns like address. Apart from mean, I would want to know standard deviation of the columns. So how I know the arithmetic mean, but how is the data? What is the variance in the data? What is the standard deviation in the data, which I can find out. I can also know the minimum value of this column, the maximum value of this column. And these are the first quartile. If you know the quartiles, if you guys know some knowledge, that this is like the first 25% of records. This is the value at 25%, value at 50%, which is nothing but the median of the data, and 75%, which is the second quartile, the third quartile. So Q1, Q2, Q3. Q2 is nothing but median. So these are the details which gives me some idea of how the values are distributed in the columns. Okay. So for numeric columns, describe is one thing. And let's say you do not have 7. So we had just 7. So I can write describe. But let's say if we have, let's say 170, then I can do a describe dot transpose, which will bring these things on the top and these things in the rows. So it will just transpose the matrix. So I'll have these count mean, and then I can have, even if I have 170 columns, I don't mind. I can scroll it and look at it. Is that okay, class?
Yes.
Class. Yes. Okay. Now, let's say, as I talked about, visualization is very important. So let's say I want to see how price is. Okay. So price, and I would want to plot this, and I see the distribution of price. Now, what do I realize? What do you know? What can you infer from this plot, class? What can you infer from this plot, everyone?
It's kind of normal distribution.
Yes, it's very close to a Gaussian distribution. And apart from some lags here and there, you can say that price is more or less normal, right? Normally distributed in the population, which is a good thing. Okay. But anyways, even if it was not, we can find out, and there are some algorithms which will come across which make the assumption that the data in a particular column is normally distributed. So if it is not, let's say the data is exponentially distributed. So what can we do? We can apply some transform in the data. Let's say the data is going exponentially increasing. So what can I do? I can apply a log transform. So a log is the opposite of exponential. So it will make the data normal. Okay. There could be times when I could have irregular data sets, and I can apply a box Cox on any kind of power transforms. So if we visualize the data, we see how the data set is distributed, how this column is distributed, and we understand what algorithm are we going to use, and then we apply the right transformation on that column so that it is in sync with the assumptions of the algorithm. Is that okay, class? Class?
Yes, sir.
Yes.
Yes.
Okay.
Yes. Yes, Avinash.
Great. Okay, now let's look at some joint plots. So here, what all you're saying is you don't have to get into too many details right now, but as a starting session, we'll see some plots, we'll get a feel of the data. Okay, so it's a joint plot, and I want to see these two columns here. So one was average area income and one is price, and I see there, okay, this is my average area income versus price. So I know I have price on this axis and I have average area income on this axis. So what does this tell me? Anyone? Plus, what does these scatter plots tell me?
There's no correlation. There's no correlation at all. Am I right?
Okay. Anyone else?
I mean,
Anyone else? So okay. So let me tell you. I think, and that's my feeling, and you tell me if I'm right or wrong, that with the increase of the values on this x-axis, the average area income, I also see an increase in the average value of price. So overall, if I say that all these points are distributed towards a line which has a slope like this, can you see my mouse, Plus? Plus, do you see my mouse on the screen?
Yep. It's visible.
Yeah. Okay.
yes, Avinash. Yes.
This is a line with a positive trend. Okay. I'm not saying that all points are obeying it completely, but if you can see this point, if I simply draw a line from the middle of this scatter plot, it will be a line which will have a positive slope, and which tells me that there is some positive correlation of average area versus price, and which makes complete sense. Because let's say area of a high house, if it is more, then the price of the house will be more. I have a bigger house, so I'll charge more money. Does that make sense? Plus.
Yes.
Yes. Yes.
Yeah. And I can get the exact number, so I can do a correlation plot and I can find the exact numbers of how much correlation is in everything. But I'm just telling you, with visual information, let's say I have 20 such attributes and I want to quickly find out the correlation. Instead of looking at numbers, I can do those 20 plots and quickly see which has a positive or a negative trend and which has no correlations. I will not get the numbers, but I'll get a fair idea of which attributes to look into. Do you get my point? Okay, so this is something which we often do with data, and this is what our data scientist is expected to do. Now, let me draw some pair plots for the complete data frame. Okay, and this will take some time because we're doing it for the data frame. And let me check. So this is running. Okay, it's done. I have a faster computing machine, but this could take some time for you. Now, let's look at this. So I'm comparing average area income and then with various other things. So this pair plot, this is comparing each one with the other. So how many were there? 1, 2, 3, 4, 5, 6. So the seventh one we know was a string, right? The address. I cannot compare anything with the address. But each one, like average area income, is compared with itself. Then it's compared with all the rest of the 5. Do you see the graph, Plus? Do you get my point? And this thing, what is this? So this is your area population, or this is your average area house age, which we saw positively correlated, or this thing, area income. These are possible. These are like kind of no correlations. But anyway, I can draw it in one go. So I can compare each attribute with other attributes. So there were in all 7 attributes, one was non-numeric. That was a string, value of address. I removed it. 6 attributes were there. I want to compare each one of them with each one. So I'll have 6 by 6, 36. I'll have graphs wherein every time in the graph, sometimes it will be compared with itself. So here average area income is compared with itself. Here average area house age is compared with itself. So whenever it is compared with itself, obviously I'll not get any correlations. I'll get simply a bar plot. Okay. Now, okay, the analysis which is observed from this data set is also mentioned here. Linear slopes, positive correlations, some blobs which is no correlation, and so all kind of relationships could be under. Sometimes linearity, non-linear, using or seeing these graphs, which I would recommend each one of you to go through these observations. And how do we conclude this? This again understands in your understanding of graphs and your knowledge of maths. But let's say if you are starting in the industry, you work as a machine learning engineer, you are asked to do this job, and there is someone who walks up to your workstation, looks at your plots, and then asks you, okay, take this attribute and this attribute, and just build this model. So as a machine learning engineer, there will be a data scientist or a assistant manager data science who will be guiding you all the time what you need to do next. Okay, when you start in the field, because there are a lot of things which you'll not know, but you will know how to apply something using Python to start with, and slowly we are expected to know everything and grow in the organization. That's another thing. So now we have observed this. Now let's take fitting the model. Let's make, now we're not doing anything. We could have done a lot of things, feature transforms and a lot of things, but we are doing a basic thing of let's fit a regression model. Let's say we do not know, we do not want to get into any of the maths or make any changes, any transformation. If we simply go ahead and try to fit a regression model to find out what will be the price column Y of our response. Okay, so we want to find out if we want to predict price. So let's look, this is my price. Look at the data. This one, this is my price, right? So let's say using these attributes 1, 2, 3, 4, 5, I don't think address will be of much use, but maybe I can do some data extraction, find zip codes, and in some area find out if some locality is really costly versus the other locality. So I can do a few things here also. But yeah, using these attributes, I want to predict the price, which is my dependent variable here. Okay, that's my intent, let's say. Because if I know that, then I can tell my sales team whom to contact for, let's say, with the offer of selling a house or buying a house, and whom to contact for rent, right? So what we do is we fit the model, and to do this, we first 5 columns, the X, and the price column Y. So we take the first 5 columns. This df.ilog : 5. What does this mean is that I take all the rows, but when it comes to columns, I only take the 5th column. Okay, so not the 5th column. So then this Y becomes df of price, which is the 5th column, and here I have taken everything, each row and each column except the 5th one. So this becomes my X. So that means X represents my independent, the matrix which has independent attributes, and in this case it will have x1, x2, x3, x4, which has all the names of age, income, all those things. Okay, and the dependent variable, which is Y, is price. Now, why are we dividing it into 2 parts? We're dividing it into 2 parts, and this division is more familiar with people who understand pandas. There's simple pandas command which I can apply on the pandas data frame, df.ilog. And with ilog, what I do is I tell that from which index you have to make such changes, and I'm taking the column-wise indexes. Okay, so in scikit-learn API, which I will use for applying this model, they expect the X to be separate data frame and a Y to be a separate data frame. Although my Y value, which is my column price, is just 1 column, but I still put it in a data frame because that's what the API expected to be. So I make a data frame of Y, and I just remove that column for Y and keep it at X. Now there is another reason why we are separating them, because our algorithm will be trained on X, and our algorithm will try to predict the value of Y. It will not look at Y. It will be trained on X, and it will try to predict the value of Y. Whenever it predicts a value, it will see at the real value of Y and see how much error it is doing in prediction. So let's say the price of a house is 10 lakhs, and I use all the attributes and try to make a prediction and come to 8 lakhs. So that means I'm making an error of 2 lakhs. Even if I go to 12 lakhs, I'm making an error of 2 lakhs. So if I'm making an error, I can find a mean squared error, and then I'll have an optimization algorithm which will try to minimize that error. So for various coefficient values of these attributes, how do I make the error minimum? And that's how my algorithm is intelligently trying to learn that what combination of these attributes can help me find the price. Okay, we'll get in the details slowly, but if you get the point, it is very important that we need to separate X from Y. That is dependent variable separately, independent separately, because we'll train our model on X, on the independent variables, find a fx, a function, and this function, which is my learned model, we will see how much error it is making and improve the function, and keep on doing that. And that the entire process is there in the algorithm. That's how the algorithm works, by using an optimization algorithm underneath, which minimizes my error, so that if I predict a price, the error is minimum. Class, do we get that? So it is important that we keep them in separate data frames, and that's how scikit-learn expects. So at this line, simply we are doing is we are bifurcating the data into 2 different sets. One, data with everything except the fifth column and the other data with that fifth column, which is price and nothing else. Okay, and this is explained here. Now, next thing what we need to do. The second thing is, okay, once we have divided the data, so I know the y and I know the x, but I also talked about that if you train a model, then you should actually evaluate to understand how good the model is. You should evaluate it on an unseen data set, on some data set on which it is not trained. So I also want to keep a part of data, both x and y, which the model does not see during the training process. So during the training process, I want to keep a part of the data. Let's say 70% of the data I'll use for training. So 70% of X values, and similarly those corresponding 70% of Y values I can use for training. So X value, I form a model, look at Y. If it is having error, I try to give the next weight so that the error is minimized. Again, pass it in the function, give some weights so that the error is minimized, and keep on doing that. Once I get a good enough model, I test this model on the unseen 30% of data. There are 30% records where I have X and Y. So I also need to split the data row wise. This split, X and Y split, is a column wise split. But I will also be splitting the data row wise, wherein I take just 70% of random rows and leave 30% of random rows for testing in the end. Does that make sense, class? Class?
It's if you ask me first time, right? It's too much. Actually, if you say that the concept you are teaching, one side is Python, that is different, that we can learn. But what you are explaining is looks like too much. There is maybe the where to start. We need to, if you have to start learning. What is the starting point? Because you are making lot of assumptions and you are telling 70% here, 30%, and I want to see the distribute. So from where the basis? I understand that's more of trial and error, or it's more of a model you are building, trying. But you can conclude on that something. But as a listener, for me, that on what basis and why are we doing like that? So some basics is required there. I think maybe the mathematics fundamentals or something.
No worry. So good that you asked that question. So no basic is required. Okay, let me tell you, there are parts of basic is required, and I'll mention that there is maths which I'm not talking about right now, but I'll still explain to you at a fairly detailed level. This part, no basic is required. So let me tell you, if I want to learn something from the data, how will I know that I have learned well? So what could be the problems if I learn from the data? Let's say, let me take an example. Let me say there are two people who walk into the bank. Okay, and I have all the features, and I'm all the features with a model. Now,
I
if
think
a
you
new person
just
walks in and I
disconnected. Can you just please repeat your last paragraph?
okay, am I audible now? I believe
Yeah,
I was
you are.
disconnected. Maybe you were disconnected. Okay, well, let me check. So what I'm saying is, let's say you have a few customers who walk into the bank, and you have made a model by looking at the data of those customers. So every day, a few customers walk into the bank, and you created a model out of it. Now, how do you know that your model is good? The only way you can know it is good because you have learned that model from those customers who have walked into the bank. So for those customers, it will work fine.
Your voice is breaking or what? I can't hear anything.
Is it breaking for everyone, class?
Yes, Avinash.
Yes, Avinash, yes.
Okay.
Now it is fine. Now it is fine. Yeah, you can speak now.
Okay. So what I'm saying is that when you learn, when you want a machine learning algorithm to learn, to create build a model using a data set of past records, the only way to understand that the learning is good is to apply that model on unseen data, on a data set where the model has not learned from. Is that correct? So if I study in the class and my teacher asks me a question and tells me the answer, every time I'm wrong, she tells me the answer. But when I'm assessed, when I go into the examination hall, I may be asked a different question. Do we all agree? Class.
Yes.
Now, so all I'm saying is that because how would I know? So I have kept a part of the data aside. I'm not looking into that data. That, let's say you have 100 questions with a teacher. The teacher only teaches 70 questions in the class. Let's say there's maths. The teacher is teaching maths and she has 100 questions to teach in the semester. She teaches you only 70 questions. All those 70 questions cover each type of question. Okay, all those 70 questions cover each type of question. So it's, let's say 70 questions have, like, there are 10 types of questions. So she is approximately teaching 7 of each type. But in the remaining 30 questions, there are 3 of each type which she hasn't taught. She hasn't taught the specific question, but she has taught the technique in the remaining 7 questions. Do you understand that, class? Now,
Yes.
what does the teacher do is she teaches you those 70 questions, which consist of 10 different types and difficulty level of questions, 7 of each type, which she internally knows, and she has taught you. She keeps 30 questions apart, which has 3 questions of each of the type she has already trained you. So there is no new question. Okay, but she has not taught you the exact question, and she assesses you on that 30% of the questions. Is that fair enough?
Yeah, this is understand. That's what the evaluation you said, right? You test with 70% of the data, and once you feel that model is in good shape, and you are trying with the remaining 30%. Correct, right? That is the evaluation, that whether your model is working fine or not.
That's right. Okay, and then again, class, this is not a mandate that you do a 70-30 split. Okay, so there are other splits which are very common, but it depends. This is the most common split, and although there is a complete mathematical explanation for why this split makes more sense, which is like the actual number is 66% to 33% is the most sensible split for train and test. That number can be arrived at and prove that this is the most sensible number for any data set. But there are other restrictions. So let's say if the data records are less. If there is less data and I have less data to learn from, the machine learning model will not learn very well. So what I can do is I can do an 80-20 split. I can also do, at times, if I have too less data, a 90-10 split. If I have too many records, there are other strategies. I can do a 60-20-20. 60% data I train the model, 20% I evaluate the model or test the model. 60-20, 60-20, I keep on doing it, but I create several models. And let's say I've created 10 models, or all of the models, 60% I've trained them and 20% I evaluate. Finally, the final test report will be on the remaining 20% which have been untouched right from the beginning. Do you understand? Because even if on the 20% I'm testing, the remaining 20% I'm testing on that data, I get an insight that maybe, okay, this is not working, so this is what I should do. So even if you want to avoid that, then there is a 60-20-20 split. That is, you build, you evaluate, and then you test on a different set altogether. Okay. So, but again, you should have ample data to do that. Okay.
Yeah, when you say evaluation, right? I understand. Example, like a last 20% when you test. So that means the bank will be having the actual data whether the loan has been given or not. So when your model gives whatever the result, and they will reality they'll compare. Exactly right. So actually our model says out of 20, only 2 of them should have been granted. But actually it's more than 10 people have been granted, means then we have to relook at our model. Am I right?
Yes. But then again, let's say 60% I keep for training the model, 20% wherein I say, okay, the model is not doing well, more should have been granted, and I retrain the model. And after getting that retraining, finally, when I'm satisfied with the model, I again test it on remaining 20%. So that could also be one of the strategies. So there are multiple train test strategies. Okay. So let's again not but understand that there is an importance of training the data on a different set and testing it on a different set. And that train test could have multiple ways and multiple reasons for it, which we could learn with time, and there is no fixed criteria. So it is more, it more depends on the creativity of the data scientist who does it.
Yeah,
But
the crux is the training. What basically you are telling is that how we are going to train the data. So that is the learning point here actually out of that.
The learning point. Yes, that's true. Okay. Now, okay, when we have done the train test split, everything is fine. This is a simple one-line code which is saying keep test size as 30%. Okay. Now one model, linear regression. Now this linear regression means it's a model wherein I have, let's say, a number of data points. All I want to do is I want to regress those data points in terms of various independent variables. So what are independent variables here? So my independent variables are the first 5 variables. Let's say here I have average number of rooms, number of bedrooms, area population, price is what I'm trying to find out. So leave the price part. So I have these other independent variables. So I'm trying to regress. So let's call them x1, x2, x3, x4, x5. Let's say I have 5 variables. I'm trying to predict the value of y in terms of these 5 variables. So what what is my algorithm trying to do? My algorithm is trying to come up with a function f of x, where x is composed of x1, x2, x3, x4, x5, so that fx can represent y with minimum error. So fx cannot exactly represent y, but what fx can do is, and how will fx form? So let's say if it is linear regression, the relationship is linear and not non-linear. So that means my x1, x2, x3, x4, x5 may be linearly related, which in mathematics means that these attributes or different vectors can only have a scalar multiple with them, and these vectors could be added up. What in other sense means is I can come up with something like a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 plus a5 x5 plus a constant c plus some error as my fx, and my intent is to minimize that error. Does everyone understand this point? This is a simple linear regression model. So my linear regression model says that if I'm trying to regress and find the value of y in terms of x, so I'm trying to find a function. Normally what we do in maths, we know a function, we put the value and we find the value of the function, right? In data science, what we are doing, we have the value of the function, which is the y value, which is the price of the house, and we are trying to come up with a function which best describes these values. Is that clear, class?
Exactly, it's very clear. The only thing, the constant you mentioned, right? So again, there also we need to assume something.
So the constant, so if you understand mathematics slightly better, you understand why the constant is there. If I do not have a constant in a linear regression equation, then what I mean is that every time my line is passing through origin, which means that what I'm saying is could be correct here, but let's say I have an attribute like age, I have an attribute like, or let's say this example itself, housing price. So what I'm saying is that if given that other attributes have some value, and if x's are passing through origin, the price of the house could be 0. But actually, even if no matter how less things are, if the age is very less, even if the area is very less, still the house will have some price. It will never be 0. Okay, so the constant is like the y-intercept, the place where the line cuts the graph. It's not always going to cut it at the origin. At times it can cut. In that case, the constant will become 0. Do you understand?
Yes,
and,
yes.
Sir, to add to this, sir, what is the coefficient value, sir? How will calculate the coefficient?
That is now this is the crux. That way of finding the coefficient value is called the linear regression algorithm. So it is your job which takes input as the data and gives you the value of those coefficients. Once you give the input of data to this model, linear regression algorithm, okay, you use this package. Okay, I can talk about the maths, but that will take sufficient time, and this session is not devoted for that. And we'll have a session upcoming in which we'll discuss the details of each one of them. But these algorithm details, they take ample time. This will take like once. So to start with, you should know how to apply it. And once you start applying it and understanding it, you can have advanced sessions where you understand how they're actually working. Okay, one common or old approach is, let's say, trying to come up with a line which minimizes the mean squared error. So if I have several points, I'm trying to come up with a line which minimizes the mean squared error. That's called ordinary least squares algorithm, common in statistics. And although this is not the same algorithm, it is slightly different. That algorithm is in a different package in Python. It's in the stats package. Okay, so this one is slightly different and uses few different things, but let's not get into the maths. Let's understand that I have an algorithm which gives me the coefficients of x1, x2, x3, x4, x5, and the intercept, which is the constant, but with some error. Okay, and that's what I'm trying to do. my intent is to minimize that error. So even if I randomly give these coefficients, let's say I say, okay, all coefficients are 1 and I start with, if I know which one I have to increase and which one I have to decrease, then the next time, the first time I can randomly give, the next time I'll either increase or decrease it in the right direction. And there's a very common algorithm called gradient descent which is used. But again, let's not get into the maths here. What you have to understand is that I can always ensure using this algorithm that I come up with the right coefficient which minimizes the error. Do we get my point, everyone?
Yes, got it. That is very clear that what you are trying to achieve is that the error margin you are trying to reduce as much as possible, so that our plan will be accurate, near to accurate. So that is the whole idea. So I have here one question here is that you are talking so many algorithms here. Here, what is the role of data scientist and what is the role of a programmer here? Like if you say like in real time, in example, this is the kind of requirement as a programmer will be getting that there is a problem in the bank and the loans are being to predict. Then what input data scientist will give? What the software engineer is supposed to do in machine learning?
Let me tell you something. Okay, a data scientist is a guy who is a software engineer, as well as a statistician, a mathematician, as well as the business guy. So I am a data scientist. I'm comfortable with engineering part. I'm comfortable with the mathematics part. I'm comfortable with understanding the business and mapping the maths with the business. Okay, so a data scientist is a very now as compared to other similar jobs, it's slightly highly paid job and a kind of noble in nature when you talk to top level CXOs of a company and you try to resolve their problem. The only reason being the person who is becoming a data scientist knows a lot of things. But this session is intended not to tell you everything of data science in one day or in one session. This session is intended to give a glimpse of data science using Python. So what does it mean is that you know little Python and you start understanding what is done in data science. You learn a little more, you acquire a job in data science. Some companies call them data scientists, some call them machine learning engineers, some call them software engineers, data science, and most of them, they something or even call them data analysts, but all of them do the same job in the beginning. Whether you're called a data scientist or machine learning engineer or anyone, you work in the guidance of a person who knows all the maths. Okay, once you start working on real life projects, you learn.
Yeah, yes. Thank you for that. But if you have to start, means so many algorithms we are talking, even gradient descent, linear regression. So what are the basics? Maybe in the end, you can say that what are the 10 algorithms to learn to start with? Maybe in the end, you can talk, you can finish your session.
You can read several blogs talking about top 10 algorithms, top 20 algorithms. You can read several blogs on the web. Let's say if you type top 10 algorithms, you'll get several blogs. What I'll tell you today is that those things are misguiding you. Okay, so it's not the top 10 blogs, the top 10 algorithms which do all the job. Okay, but I can tell you what I am talking about, like linear regression, logistic regression, and decision tree. So if you look in the BFSI sector, banking financial sector, the three things which I'll talk about in this notebook, and all three means I've dealt the first one in so much detail that the rest three will be easy. So what you realize is in the BFSI sector, they are used most of the times. Let's say 60 to 70% of times, these are mostly used algorithms. Okay, still I don't say they solve all the problems. Okay, and there is nothing like top 10 and top 5. There's nothing like top. Given on a data set, any algorithm could work better depending on how the data is lying on a multi-dimensional plane and what assumptions of the algorithms hold. Okay, and that involves a lot of maths which we are not starting with, or which I'm even not guiding you to start with. I'm guiding you to start with data science and slowly learn it. Do you understand? Means there is no quick fix if you want to be better.
That's it. Thank you. Okay? Thank you very much. Thank you.
So now let's understand the good part of Python is, or scikit-learn API is, the way I build one model, I can create many models. So let's say I have a manager or a data scientist I report to, or assistant manager data science, and he tells me, okay, on this data, you do a regression using linear regression, but then he comes and says, you do a support vector regression, or you do a random forest regression. You will realize that in all the three cases, you do the same steps. And I'll do other things, and you will realize that you do the same steps. So The engineering part, it becomes very easy when it comes to scikit-learn. Okay, it makes the engineering part very easy. So we'll do it not only for regression, even for classification algorithms, and we have some examples, and you'll see the engineering part is so easy. So let me just take you through the crux now, because first time it takes time, last step is left. So we did a linear regression model. So the equations are, first time you do is you make a train test split. Once you've divided the data into train and test, all you do is you import the model you want to run. So linear regression algorithm is what you're going to use. So you imported linear regression. You created an object reg of linear regression. Then you do this object dot fit. Dot fit is what you write every time, whether it's linear regression, logistic regression, decision tree, support vector, random forest, uh, any algorithm in scikit-learn. The complete scikit-learn API, they have fixed ways. You always import that model. So in terms of logistic regression, you'll import logistic regression. In terms of decision tree, you'll import decision tree. You always write like that. Whatever you imported, you create an object of it. You say model is equal to and something, or reg is equal to something. Okay. And then you always do a dot fit. Dot fit will have two parameters. You pass the training of X and training of Y. So what it will do, it will try to come up with a function for X. By comparing it with Y, it will minimize the error of that function. Do you get that? And it will build a model for you. So the output of reg.fit is the linear regression model which you have created now. Okay. Now you can use this model to predict. So the next question what you will do is you will do reg.predict, and you can predict it on the test data. So on the test data, you will make your predictions. And once you have your predictions saved in predictions, or you can directly do the reg.predict, it will give you this output. Or you can save it in predictions and then write the predictions. So these are the outputs. What is this output? These are the various price of houses of the test data set. So test has X values. The X values are passed in the model, which is already created and saved in linear regression. On this X, this model has, what is this model? This model has all the coefficients. Okay. So this model has saved all the coefficients what you have got. Okay. And now based using those coefficients and the attributes. So for the new data, I know the attributes. I know what is the area of the house. I know the number of rooms, number of bedrooms. I know all that. Okay. And I know the coefficient of bedrooms and coefficient of the area and everything. So using that coefficient which I have learned in the model, I'll do the prediction for X and I'll get some values. These are the values which I predict. Now, how much error am I making? I can compare this value with the Y test values, which I haven't used till now. So I have an X test. I also have a Y test, the 30% of Y. This is the 30% of test, the X on which I have tested, and I'll compare it with the 30% of Y. And because it's a regression technique, I want to find something like a mean squared error. How much is the error from the original value? And I want to minimize that error. So I can have something like a percentage error, or I mean, there are various, there is something called R squared or adjusted R squared. Those are the matrices which I'm looking at to evaluate how good my model is. Is that clear, class? And next thing, okay, so my model was saved in reg. I can do a reg.intercept and reg.coefficient. What is this giving me? This is telling me that this is what the intercept was found for the model, and these are the coefficients for all the 5 attributes. 1, 2, 3, 4, 5 attributes, 5 coefficients, and this is the value of intercept. So minus 26,46401 is something is intercept, and these are the coefficients 2.1, 1.6. There are other things. It's not the best model. Can someone tell why it is not a very good model? Although we did not do anything, we simply created a model. So, and we did not do it iteratively, we did not improve it. So we haven't got the best model, but we are learning how to quickly make a model. Okay, making it best will depend on how would you realize where it is not going well. Okay, so I'll tell you there are reasons because of which this is not a very good model. The first reason is the coefficient is very high. Coefficient is very high versus the the intercept is very high versus these coefficients. So intercept is driving everything in the model. Okay, and there could be various reasons for it. One reason could be this is a regression based model. Maybe I should have normalized the data sets. I have done various things on it to make it better. But what we are learning is in the scikit-learn API, it is good to quickly make a model. Let's see, even if I'm saying it is not the best model, how good it is. Let's see. So let's do a R squared. Class, do you know what is the R squared? Anyone in the class? Class, anyone? Okay, no one? Okay, so R squared value, so R is the coefficient of correlation, the Pearson's coefficient. R squared value tells me that if I have not used this x values, if I have not used this x1, x2, x3, x4, x5, so if I just have the price of the houses as the only data set I have, then what will be my best prediction? My best prediction will be the mean of the data. Do we all agree? Class, if you just have the price and I asked you what will be the price of the next house, how would you predict it? The only thing you can do is you can predict the mean. Do we all agree?
Yes.
Yes, because mean will minimize the error. If you all understand arithmetic mean is a number which minimizes the error from all the data points scattered around the mean. If we predict mean, I'll have minimum error, right? So in order to minimize the error, I will predict the mean if I just have y. But because I used some x, I reduced my error. How much errors did I reduce? So R squared value tells me that actually I reduced 8% of errors. That means how better did I do instead of predicting with the mean. So I did 92% better than predicting with the mean. So even without applying a lot of things, and even without, when I say that okay, intercept is high and the model is biased and all that blah blah, you can be correct 92% of the times. Means your R squared means you can do 92% better than if you're making a guess of average value of y. So do you see the power? Yes.
Yes.
Yes. Okay. So this is the power of these algorithms. And again, there are a lot of things which are, let's say, abstract, not the part of this webinar as such. But once maybe if we are connecting in some other sessions where we have to get into details, I'll get into detail and tell you how can we improve it, what iterative ways we can do. Okay. Now let's look at some classification algorithms. The other problem where we want to know whether to apply the accept the loan application or reject the loan. Okay. So let's look at that. For this one, okay, we want to see the distributions of the predictions. We want to see how the errors are plotted. So we see the data set was normally distributed, and we also realize that price was normally distributed and the errors on the price is normally distributed. Now, why are we seeing all that? Because we also know the assumptions of a regression model. So if we are doing a linear regression model, the model is good as long as the errors are normally distributed around the data. So it's not that I have in few cases more error and few cases less error. Overall, the error should be normally distributed around the right result. So which means my model is okay. It's good enough to be used. It's robust. Okay. And let's do, okay. Let me just do something more. Let's do the first logistic regression. You can go through this code. Everything is written here. And once we share the file, you can also get into the details of reading all these things and understanding it once again. You can connect us and ask questions. But the major intent is that you understand that scikit-learn API is helping us quickly build models with less knowledge of maths, good models. Are they the best, or can they be used in the industry as it is? No. Trust me on that part. You would need guidance, you would need improvement, or you need to learn the maths on your own, or you need to read a lot of books on your own to make it better. But to start with, you will do a fairly good job even without knowing much of the things. That's the message I want to convey. Okay. Now let's take next algorithm, which is like classification, whether to accept or deny loan. Okay. So we'll be dealing with one algorithm called logistic regression, which is again a linear classification algorithm. So like in the above cases, if I wanted to not find out the price of the house, but wanted to find out whether he will buy or rent a house. So what I'm doing is using these 5 attributes, I want to come up with a plane. Why I'm saying a plane? Because it's no more a line if I'm going in more than 2 dimensions. So in 5 dimensions, it's a plane. This hyperplane is trying to segregate the 2 classes of buy a house versus rent a house. Or in this case, the division is something different. In this case, in this example, the data set is of Titanic. So we all know the Titanic ship which sank. And in this data set, we want to find out using the data itself that what were the attributes which could help me determine whether the passenger survived or the passenger did not survive. Okay. So Titanic dataset is available open source. So you have passenger IDs, you have a Y value which is survived and not survived. You have the class, ticket class, first class ticket, second class, third class. You have the gender, which is called sex here. You have the age. You have the save SP, there's number of siblings or spouses aboard the Titanic. You have the parts, number of parents or children aboard the Titanic, the ticket, fare, cabin, and embark. That is the port from where you boarded the ship. So you could have boarded Titanic from Cherbourg or Queenstown or Southampton. So which port did you choose to board the ship from? Okay. So this ship sailed, and as we all know that the ship sank. But let's say if we have the data, if we have the details of let's say the class in which, so we know that maybe the people, the females were the ones who survived, or people tried to save them more, or children survived, or people in the first class compartment survived. So let's verify things some data, and let's see, can we find out from a data science perspective who survived and who not, what was important, what determined the survival in that case when this mishappening occurred. Okay, so let's see. Again, the rest of the things are same. We see the info, we see all the details, we see extraneous variables like name and tickets, something which we see that they are of not useful. So a person's name will not determine whether he will survive or not, or his ticket number will not determine anything. So I am not using these variables because they will not determine anything for me. Okay, then multicollinearity is there. Multicollinearity is a term used when one thing is correlated to the second thing and second is correlated to the third thing. So maybe if I see that most of the people who boarded the ship from Southampton, they boarded the ship in the first class compartment. So then that's multicollinearity. Two attributes but both giving the same information. Okay, and that's sometimes not very good for algorithms which are linear algorithms. Even linear classifications like logistic regression is a linear classifier. Okay, so let's say nothing else we do, we find out the mean of people who survived. So how many people survived? So we see that, okay, various means. Passenger ID is not very useful. Class. So we definitely see that person's class who survived is 2.53 is the average. There is 1.95 is the average of who did not. Uh, Let me see. What is this? Survived 0. No, survived 0 and 1. This it's not very useful, but you can get the average age of people who survived or not survived. Is there any distinction? Can you see any distinction? Not much distinction is available. But just by looking at the age or the class or passenger ID or how many siblings is possible, you see they are more or less the same in most of the attributes. So you cannot pick something and say that this was the reason. But taking a combination of these attributes, that could help. Okay, and that's been done in this data set. So in this data set, we are using a tree-based algorithm, and this algorithm, let me just check. So there are various things. You are seeing how many, you are doing a data analysis. You are saying how many males versus females, how many parts, how many people with 678, with 0 family members, with 1 family member 118, with 2 family members 80, with 5 family members 5 people, with 3 family members 5, with 4 family members 4, with 6 family members 1. So you're getting all this information, right? What is the classification in the data set? You do all the exploratory analysis, you handle the missing values, you see these values are missing. You cannot pass the missing values, and this is covered in detail in the data manipulation class. So you need to remove those rows or you need to impute some values there. But you cannot have missing values or any values given to an algorithm. It will throw an error. Okay, so you can find the missing values, and then either you decide to replace it or impute it is a second decision, but you can definitely find is null.value counts, how many missing values are there. Okay, and we will quickly look at the algorithm we applied here. We basic analysis, you will understand this. You have done a correlation plot for each. Is passenger ID correlated with survived, correlated with P class, correlated with age, correlated with parts, correlated with sex male, correlated with embarked queue. So you will do a correlation, complete correlation matrix, one with the other. So you see this is x by x. Those many, if there are n attributes, n by n matrix. Okay, and now you do a train test split. This time we are running logistic regression, exactly similar thing. From sklearn, linear model, import. This time instead of linear regression, logistic regression. Again, we can call LR. There we used to call it reg. We said LR is logistic regression. We do a LR.fit, and then we do a predict, and then we do a evaluate, and the evaluation is mostly the confusion. So how many of you know these things? Confusion, accuracy, and classification. Class, do we know these things? Class. how do we realize that a classification decision is correct or incorrect? Class?
During evaluation?
During evaluation, but how do you evaluate? For a linear regression algorithm, I said that we will take mean squared error, how much away from the mean you are. Okay, so let's say the price of the house is 10 lakhs and you're predicting 9,89,000. Your error is 11,000 on 10 lakhs, right? Which is not much error. Do you understand that part?
Yes, yes.
But my question is, if I'm doing a classification, let's say whether to approve loan or disapprove loan, when am I wrong?
From the predictions, I think
Yes.
what are the predictions?
Okay. So let's say if I say in this case, there are two predictions in case, whether the passenger survived or he did not survive. Okay. So if I say that someone survived, if my model says someone survived and that person did not survive, then that's a wrong decision and I'm wrong. Right? Plus.
Yes.
Yes. And
Yeah.
if I say that someone did not survive and he actually survived, then also I'm wrong.
Yes.
Yes. So that means I'm wrong in two places. And in two places, when I say someone survived and he actually survived, and when I say someone did not survive and he actually did not survive, in those two places, I'm correct. Right? So
Yeah.
we would want to know that where all we went wrong and right. Okay. There is a very popular thing called a confusion matrix. So you all can see my screen, right? So let me show you something. So what is a confusion matrix is? Confusion matrix is about, and don't get confused, but go ahead and read this page. So confusion matrix is about like this. Let's say I have to predict cat versus dog. Okay. So in actual class, there were 8 cats. Okay. Cat is 5 plus 3, 8. This is the actual in the horizontal direction, the x-axis direction. You see, actual class, there is 5 plus 3, 8 cats. But my prediction algorithm said 5 were cats and 3, which were actually cats, my algorithm predicted it as dog, which could happen, right? Class.
Yes, yes, it can happen.
Yes,
Yes.
it can happen. Now, next time, actual class was dog. So I had again 5 dogs, 2 plus 3, 5 actually dogs. But my prediction algorithm caught 3 of the dogs correctly. 2 of the dogs had predicted as cat. Here also it was wrong.
Yes.
Agreed?
Yes. Yes.
So
Yes.
you
Yes.
see the things in bold, 5 and 3, where cat was actually a cat and was predicted as a cat, and dog was actually a dog and was predicted as a dog. This bold things 5 and 3, these are the places where I'm doing correct, I'm making a correct decision. Right? Whereas these things which are not in bold, these are the places where I'm making an incorrect decision. Is that correct, As?
Yes.
Yes. So this entire thing is called a confusion matrix. Okay. And there are a lot of reasons. There are various attributes. If you look into this, go ahead and read this page sometime, because again, as I said, this class is not intended to do that. But you will read that there are many things. And this is a very, very crystal clear page. It's simple English, no deep dive maths. Only maths required is class standard 8 maths. Okay. Just counting is required and nothing else. And you'll find something called true positive, true negative, where true positive is something where something was actually true and you predicted as positive. So that's called true positive. False positive, when something was actually false but you predicted as positive. True negative, when something was true but you predicted as negative, right? So just read these things and they tell me overall that how good my decision was. Okay. I can compute various things on top of that. So let's say in this case, if I want to compute accuracy, in this example, cat dog example, my accuracy is 5 plus 3, 8 divided by 5 plus 3, 8, 3, 11 to 13. 8 by 13 is my accuracy. And my error is 5 by 13. Do we all agree?
Yes.
Yes. So it's fairly easy, but accuracy is not the only thing. Okay. Because there are reasons why it is not the only thing. And then you'll have various things like sensitivity, recall. Sensitivity and recall is the same thing, but sensitivity, precision, F1 score, various things are there. Okay, these things, accuracy, F1 score. Please go ahead and read this page. And because you guys are
So in
attending
this case, Yeah, in this case, you said that, right? Now, if you say 8 by 13 is right, 5 by 13. So, how do we take a decision that, okay, this much error we'll accept? Is there something like a confidence level or something that, okay,
The
the,
confidence
only.
level, yeah, confidence levels can be given. So in normal regression models, you assign a confidence level, but usually what you do is you try several models. So for classification, logistic regression is not the only model. You have decision trees, you have support vector classifiers, you have k-nearest classifiers, you have random forest classifiers, you also have neural network classifiers. So you have various classifiers, and machine learning is a very big field. Scikit-learn API, the way to import a model and do a classification job is simple, but maths of each of these models is different. They have different assumptions, and they will have different results on the data. Okay, so that's something which takes time to learn which one to apply, how much to accept. Plus there is a business guidance there. So if the what you see is, without your model, how good is the business doing? Let's say if you're not doing if you're doing not very well without your model. Let's say my in the bank, I have the past data. I have seen the number of times bank has approved the loan and the person did not pay the loan. I know, if I can reduce that number from my model, I can show it in the past data that if you would have used my model, you would have saved this much loss, would have mitigated this much loss. That means my model is better than whatever the bank is doing. Do you understand that? So it's not about how good I am. It's about, am I better than the existing way to solve that problem? Some problems are complex. So for those problems, if I am achieving a 60% accuracy using data science, it's very good. The problems like sarcasm detection. If I'm trying to detect whether in a speech someone has been sarcastic, it's a tough problem. People while talk, they become sarcastic and often we do not note, right? So for that problem, even 60% accuracy is very good. But let's say there is a problem like loan prediction. At times, your models can take you to 90-95% quickly. Okay.
So
So
yeah,
it's more.
here the question is, we are training the model and we are delivering the solution, right? How we
Mhm.
continuously deliver, like a more customer come, because it happens like 2021, 22. So the year goes, the data gets keep updated. Then our model also what we train might start failing also, right? Due to
Wow.
economy or whatever. So how do
Very good
you?
question. Very good question. So the assumption is that if you are training your data on the if you're training your model on the past data, if the distribution of the data changes, let's say there is a macroeconomic change, the government change and the norms, the banking norms, guidelines were revised, and there was a major effect, then your model needs to be updated. But how would you keep a tab on that? So easier ways, there are some Bayesian algorithms which can help you keep a tab on how good your model is working. Okay, see, because you would always know whatever predictions you make in the later. So today you tell me, okay, go ahead, predict the loan for this customer. But in the future, you would come to know that whether that customer paid or did not pay, right? So you keep evaluating your model. If you realize that your model's performance has dipped, it's good time to update the model. Although there are other ways, there are Bayesian ways of finding it in advance, but that's not where we are in today's session. Okay, so we can discuss in some other session, but in today's session the intent is how to just make a model. But the question is extremely good, so we have to be cognizant that this model is based on past data. Assuming that the distribution remains the same, the model will work fine. But the moment things change, the model will stop, the performance will dip, and I need to keep a check on the performance, which will make me realize that it's good time now, I should update my model, recreate the model. Does that answer your question?
Yes,
Plus,
yes, yes. It's
this
and
again,
one more question, simple, just so we are using so many algorithms. So the Python is giving built-in. That's why we prefer Python. That is one thing.
all languages are giving built-in. Trust me, all languages give built-in. No one codes the algorithms from scratch unless and until he has like extensive experience and he's trying to solve a problem where existing algorithms cannot help him solve the problem. So I have done it in the past. I have created algorithms from scratch, but the only reason was the existing algorithms could not be applied and they were not solving the existing problem very well. So I created something combining what I've learned of these algorithms. Okay, but that's rare in the career, and that's only when you grow a lot and you understand all the maths. Usually what you do is you apply the existing algorithms and solve the problems.
Okay.
Okay, Okay, so in this case, the confusion matrix, the same thing, true, positive, false, positive, it is telling where all you went wrong, right? And you have those results like accuracy and everything. The accuracy result for this logistic regression is 82.46. That is, in 82.4% of results, you were correct. The rest of the results were either you predicted not survived, where it was actually survived, or you predicted survived, where it was actually not survived. So 18% you were incorrect. Okay. And similar to this logistic regression, there is a tree-based model, decision tree. Again, we're not getting into the algorithm, but the application is exactly the same. So you divide the data, you do the accuracy score with the tree model, and you realize you can also make a tree, the decision based on that model. So you let me just show you a tree. So a tree-based model is taking decisions like let me just make the page smaller a little bit. Okay, so something like this. So it's a smaller tree, just 2 level, just to show you, but you can have a bigger tree here. So it's like, first thing it is looking at the gender of the person. If it is less than 0.5, that means if that person is a female. In that case, Gini is something which is to do with the algorithm itself. Then for these many samples, 62.3% of the cases, you can say that the person either survived or not. But the next decision you are taking, so this is like how explicit you can be. You can explain to the business, look at this attribute, and then at this, and then at this, and here you take your decision. Okay, so there are various logistic regression, decision tree. There are various models to classify, and all these models have very different maps underneath. So a decision tree is very, very different from a logistic regression. The way logistic regression is classifying is very different from way the decision tree is classifying. But the easy part for someone to start in data science is that everything is built on the scikit-learn API, which is used in a very similar fashion. So you use linear, logistic, decision tree, anything you use, whether classification, regression, all you have to do is you have to create a model, save it by a name, you have to predict, and then you have to find the, let's say, whatever accuracy or root mean squared error, whatever you're trying to look at. So every time you create a model, you fit the model on the data, you predict on that fitted model, and then you, depending on the evaluation, whether it's classification, then you can go for confusion matrix kind of thing. If it's regression, then you go for root mean squared error kind of thing. Okay, but everything else is same. You can see 3 different files, 3 different classes, and we are performing well on each of them, but we are not trying very hard on any of them. Okay, to start with. Now these things are not the best models, again, they are the base models. But yes, let's say you're working under the guidance and you create a base model, then that person can guide you, okay, make these changes, and that way you will make this model better iteratively, and also you will learn on the job, because if it tells you to do something, he also tells you why you're doing this. Do you understand my point? So the intent is that you can quickly get into data science having minimum knowledge, and you can learn on job, versus you do a MS of 2 years and a PhD of 3 years and you learn in 5 years and then look for a job. Do you get my point? Class?
Yeah, got it. Yes.
Yes. Also, all of you, my details are there and it will be shared by Paras. So you can feel free to reach me if you get stuck somewhere, if you need any clarification, guidance in terms of data science or anything. Okay. And
Sure.
hopefully,
Yes.
yeah, we
Sir,
are
I
running
have a
short.
couple of questions, sir.
Please
Sir,
ask.
yeah, sir. In
Yeah.
case of in case of large data set, if there is not applicable values are there, like, how to find that those values? Is there any automated?
Yeah, it's a single one-line code. Is NA, so you have a data frame, you write, you call dot is NA is a function, and then dot sum. So you can simply see all the columns wherever NA values are there and how many NA values are there. And if you want to replace those values, you can also call dot fill NA. So pandas have made this thing super easy. Everything is present in the previous session. The previous session where you have data wrangling and data manipulation, the session which we talked about in the beginning, that there is a previous session where you know how to use pandas to do things. Okay, so in that session these things are dealt in detail, and the session is available in the YouTube link.
Okay.
So I believe everything will be shared with you, right?
So one more thing, sir.
Yes.
Yeah. For example, we are applying the model on the existing data, right? We are applying different kinds of model on the same data set. like how
Yes.
we can improve the model. So we are improving the sense, what we are doing is that you are doing the data cleaning or feature extraction. That's what we are
Yes.
doing, right?
Yes.
That's what we are improving the model. Is there
Yes.
anything like new novel algorithm or novel model can be created? How it can be created? Is it, how it can,
Okay.
uh,
So let's understand these algorithms are not magic. So uh, when you say improving the model, how do we improve the model? By doing a data cleaning or feature engineering. We improve the model because we know the assumptions of the model. So I know that a linear regression model is expecting the attributes to be normally distributed, and I know this attribute is exponentially increasing. Let me take a log. Let me take a log of this attribute, and then it will become normal because I know the basic maths. Or let's say this attribute is not very normal. Let me do a box Cox transform and transform it to normal. Then apply a regression model, and I know it will perform better. Let's say I realize that the data set itself seems like it is not distributed linearly. It may have a non-linear distribution. So I will not go for linear regression. I can go for random forest regression. Do you understand my point? Right.
yes,
So
yes,
there are things. So when you know the maths, you know that what is the model assuming because you understand how that model is derived. Okay. But to start with, you may not know all because even if I tell you all, there are thousands of things. You will get confused. You will not take anything back home. The intent is not to confuse you in this lecture.
yes, yes. Understand. Yeah.
Okay.
Thank you.
Okay. So, class, we're running sort of time, but it was a pleasure meeting you all. And feel free to email me offline or whatever contact is shared, and these slides and these codes will be shared with each one of you. Okay. Does someone want to say something?
Yeah, it's a very good session. Actually, we didn't expect that this will be this much thought-provoking. Actually, it given the strong base because all those days there was a confusion on data science and machine learning. All now we know the clear demarcation where to work and what to get everything. So it's very good, and thanks for that. Thanks Avinash for giving such a brief session and patiently answering to all the questions, though many of them not relevant to this session, but still you answered. So thank you.
Thank you for the wonderful feedback. Thank you all, and I would expect each one of you to work hard, get into data science, and we are looking for new people. The world of data science is sort of we have a huge shortage of resources. Okay, so we want each one of you. In fact, MS Reactor is also trying hard to ensure that people get into data science. And all I wish to say is that a little knowledge and a belief that okay, you will learn on job. That's how I learned. I learned on job. Okay, it's not that I did a degree or MS or a PhD and then I started learning. I learned most of the things on job. So I did have a certification, but that wasn't much. 90% of the learning came on job. So even if you have a MS from some university in US, you will not know everything of data science. Still, 80% of the things you will learn on job. Okay, so trust me on that. So when you have to learn on job, just know the minimum basics to get started with, and then start your journey of data science.
So
Okay.
is there any other basic tutorial to start with, like just because not everyone gets opportunity in office to work with such. So for them, any guidance like a YouTube or somewhere blogs or something, we
There
start
are
from
multiple.
basics.
So for this MS Reactor previous sessions, I believe Paras will be sharing the content. So they have various sessions from various uh, people on various topics, slightly different topics, and they have it in some order. So they tell you first learn manipulation, then machine learning model, then this. So it's in order. So it's better to go through that resource. The link will be shared with you. You'll have YouTube videos. You'll have these sample codes, and you'll have the recorded sessions to guide you through. I mean, that's one of a good starting point. Although there are umpteen resources even on the web, but most of the times we get lost in the resources. So I would say let's start in a streamlined, structured fashion, the way MSD this team is guiding you. Okay, and that will work best for both the parties. Am I clear enough?
Yes.
Yes,
Okay.
yes, sir. Sir,
Yes,
I
yes.
am a beginner that I am from third year college. How should I start for the data science? Any courses like that should I should follow?
Okay, guys, I believe most of these questions could be answered by Paras. So the one who introduced the session, who started the session, So he is the guy who will guide you, all of you, on your journey and how to start and how to do things, right? So for me, you guys can ask technical questions. So let's say, Avinash, I did linear regression, I reached this result, and this is what I studied in some book, I do not understand. I'll try and clarify that to you. Okay.
Perfect.
Yeah, okay.
Okay,
And
because I am not the guy who knows a lot of courses and all. So I just train and work on projects. But Paras will be able to guide you. Let's say you're in third year, he can give you a customized guidance. Okay, what should be your next step? Is it okay? He's more of a counselor.
Yeah,
If you understand me. Okay?
yeah, sure.
perfect. Then, thank you so much, Avinash, for the
Thank
session
you,
and
sir. It was.
patiently taking up the questions. Uh, this was the whole plan, right? Like you can talk to people and they can really ask questions. So I guess that went well, and we can only listen to the feedback. Everybody just loved it. So yeah, kudos to you and to everyone, those who have joined. And like everyone asked for the session, so these all are free to join. You have such amazing people coming up. You should use the opportunity to connect with them and to learn from these sessions. You can find all of them on the meetup page, and just be there. Like you're most welcome. We keep on doing Azure happy hours on Fridays. You can join. All of these are different sessions on different kind of topics. So just pick it up and be here, be our guest, and then yeah, like we'll keep on hosting such sessions. And anything specific is there, you can just message me, or like drop something, or probably write to me on meetup if you want to, and I'll try to respond as per the questions. So that's about it, and thank you very much. Thanks, Avinash, for your time, and
Thank you,
thank
guys.
you,
Thank you.
Kunal.
Thank you, guys.
Thank you, Paras and Avinash. Thank you.
Okay, bye bye guys,
Thank you,
have a good
Paras
night.
and Avinash. Thank you, team.